Where I told you they were before you hugged your boyfriend by like you were both going off to war and not class.
I know what you're talking about.
Bro, some of these kids are always chill.
At least
Amen.
Yeah. It's not that.
Like, you're gonna see her next year again.
I'll never let go, Jack. I'll never let go. Oh, children.
Like, there could be a school shooting and you could die next period. You never know.
It is recording all of this.
You know, PSA. Can you please pause it?
Nope.
What's PSA?
No, bro,
I don't know. You couldn't make it to next period.
Whoa.
Recording for a minute yet?
I would make it.
It's really that dangerous out here in high school, bro.
Okay.
So many words. Okay, so a rhombus is a leaning square. The plural of rhombus is rhombi, not rhombuses. Just like the plural of syllabus is syllabi, not syllabuses.
I thought it was a syllabus.
Just some knowledge for you guys. Because y'all scaring me. Alright, so what we're going to do is we're going to talk about the properties and then we're going to work out the problems. Just like we did with the rectangles. And maybe you'll know a little bit more than what you did before. Maybe. Fingers crossed. Alright, so let's start on our rhombi page. 6.5, part 1. Now, our learning target for today is going to encompass both of them because we took so long on our rectangles yesterday. So please write your learning target that's going to cover both of these things. It says, I can recognize. No, I didn't. It's right here, but I'm just not writing right there because I write big. Boom.
I can put it in the bottom corner.
I can recognize and apply. I'm just ignoring you. Properties of rhombi and squares.
I know, but rhombuses sounds better.
Not anymore, not just saying.
When I think of rhombi, I think of cacti.
Which is the plural of cactus.
Yeah.
And not cactuses.
But I don't know how I feel about
Cacti is a smooth name, though.
I feel good about platypi.
Like,
platypi.
like the nickname for your friend could be
I like Harry.
Alright, you want mini platypi, not a platypi, because a platypi would be a platypus. Alright, here we go. We are not digressing anymore. Alright, so a rhombus says the diagonals are perpendicular. So what are diagonals? What do those look like?
Not straight.
So from one corner to the other, we could use our words. So if we...
Look like.
If
Like three of us were like, look, not sound. What?
Are you taking Curtis's place today and arguing my side? Okay, so if we label this rhombus with A, B, C, D, where would we put a diagonal? From what point to what point? A to C and D to B. Both of you take a point. Great job. So I want you to create one, please. Use a straight edge.
No.
Wow, use a straight edge.
I did. The end of my pencil.
I like that.
Alright, I need you two to calm down over there.
Colors is like
Heather.
That's my favorite show.
Alright, the diagonals are perpendicular. So what does the word perpendicular mean?
90-degree.
What do you mean 90-degree angle?
A cross 90-degree.
Alright, so we would put a, good, Drake, take a point. We would put a box right here, correct? And that means that all of these are 90 degrees. Does everybody understand? Alright, then it says each diagonal bisects a pair of opposite angles. So if it bisects angle B, what do we know about ABD and BDC? They're congruent. So how many moons would we put? Rainbows. Sorry. How many rainbows would we put? You would put one rainbow right there. That's all I want is you just tell me to put one rainbow right there. Now, since it's still a parallelogram, right? What do we know about opposite angles? They're opposite angles. They're congruent, right? So how many moons would we put down here? We would put one moon rainbow here and one rainbow here. Does everybody understand? Because they bisect, which means it cuts in half. So if these two are 30, the whole angle is 30, that means when it cuts it in half, what's ABD? What's CBD? What's ADB? What's BDC? Magic! Take a point. Try to sound like I'm not killing you. Now, what do we know about angle DAC and BAC? What do we know about DAC and BAC? They're congruent because it bisects. Would I put one rainbow this time or two? Two rainbows because it is a different angle and they are not congruent. Angle A is not congruent to angle B. Drake. At least you're listening today, but don't sound like I'm killing you, son.
It sounds like what's the donkey off of Winnie the Pooh?
How? We're just drawing rainbows.
Yeah, I want to say Eeyore. Yeah, you sound like.
Okay. Now, then it says all sides are what? So what would we put on there? Let's use our bottom one and put tickies. How many tickies would we put? One on each side. It's not a square. No, why is it not a square? It doesn't have right angles. Take a point. Alright, and also, okay, it says all sides are congruent and opposite sides are parallel. What do we know? What do we use to mark parallel sides? Arrows. So I'm going to put one here. How many am I going to put on the top and bottom? Two. If you answered either of those questions, take a point. Label your bottom rhombus. Yep. Because I wanted someone to ask that question. Alright, now it says the consecutive angles are supplementary. What does it mean about consecutive angles? What does it mean about consecutive angles?
They are congruent.
No, guys, now, what does the words consecutive angles mean? I'm not asking you what supplementary means. I'm asking you what consecutive angles mean.
Together.
What does that mean?
They make 180.
No, that's not. I just said the same question 3 times and you still answered it the other way. Now, what I'm asking you is what are consecutive angles? So find on this rhombus 2 consecutive angles. E and I. E and I are consecutive angles. Now, what does it tell us about consecutive angles? So what does the word supplementary mean?
180.
180. So that means that angle E plus angle I would equal what? 180. Now, would I ever set EI and FG equal to 180?
No.
What are EI and FG?
Angles. They're lines.
No, what are they?
Lines. Angles.
Drake, stop talking. Yes. What are EI and FG? They are parallel, but what are they part of the rhombus? They're sides. I know, but you're just saying stuff just to say stuff, and it's annoying, so I'm ignoring you.
You said it, and I said sides.
I know, but I'm ignoring you.
Oh, okay, I see how that is.
Okay. Now, you don't set sides equal to 180. You also don't set them equal to what? 90. What do you set equal to 180 or 90? Okay, hallelujah. Now, what does it tell us about opposite angles? So what kind of rainbows would I put on F and I? One rainbow. And what kind of rainbows would I put on E and G? Alright, let's look at our problems. Are we ready? Now, before you tell me that you don't know how to do something, you are going to 1, read the problem, 2, look at your notes, and 3, think before you speak. Does everybody understand? Except for Ainsley, who was talking while I was talking. Let's look at number 1. The diagonals of a rhombus FGHJ intersect at K. If the measure of angle, put a little angle symbol right there. Sorry, I forgot to draw it on there. FJH is 82. Find the measure of angle KHJ. So let's highlight first what they gave us. Like we did yesterday, 42 times on our rectangle. What do they give us?
FJ.
And where is FJH? Highlight that. Now, before you tell me that you don't know how to do this, I want you to read back at the top what it tells us about the angles of a rhombus. And then I want you to think of what property we can use to apply to this problem. So we should be looking at our notes because our rules aren't up there.
Opposite angle.
Wait. Now, what angle is it asking us for? KHJ. You don't have to highlight this. I just want you to watch. That's this one, correct? So, is that opposite of angle J? So, could we use the information about opposite angles? Nope. But what could we use? Consecutive angles. What do we know about consecutive angles of a rhombus? They're supplementary. Now, if we use consecutive angles, that's going to give us this entire angle right here. But what do we know about the diagonals of a rhombus? Cuts what in half? It cuts the angles in half. So, what would we have to do to get this angle? Divided by 2. Now, what would we do with angle J and angle H to begin with? Alright, so we would do 82 plus X, which is what we're looking for, equals 180. Why did we set it equal to 180? Because they're supplementary, because they're consecutive angles. Good, take a point. Now, what would I do from here? Alright, good, take a point. And what's 180 minus 82?
98.
Now, that gives me that entire double rainbow. But do I need the entire double rainbow? What do I need? How would I find half? Alright, do that. Did you get 49? Look at us go. Now, after our week of struggling with rectangles, had I given you maybe about another minute, could you have figured that problem out on your own?
Yeah.
Had you just read it? Why, Emilio?
I don't know.
You don't know why?
I don't know.
You just don't have confidence in yourself?
I don't know.
Okay. I feel like you could have. Alright, let's look at number 2. That should. Oh, Blair. That should say GF. I'm pretty sure. She's just stretching back here. She's not dying. She is not so terrified of this problem that she's dying.
And I didn't realize how big you write until I look down on my paper and see how much space I have compared to what's up there. Alright? It doesn't look that big. You look at my paper.
Why is this a conversation that we're
I don't know,
having?
it just hit me, and I wanted to speak this. It's like you.
You should also be working at the problem. I'm ready for it.
What are you working on?
I'm ready for it.
Come on.
Oh, I'm so excited about the next one.
What we're doing, or
Oh, and we could have done GH. It didn't have to say GF. Because what do we know about all sides of a rhombus? They're all congruent. So did I really have to change that? I just got excited.
Yeah.
Oh. Emilio, you spent 2 periods with me and you feel all forceful all of a sudden.
Oh no, I was thinking.
Is that X plus G?
I'm proud of you. It's a 9.
Oh.
It's just in fancy font. It's a 9.
oh, it is. I got real confused for a minute.
Going back up to the
I
other
thought
problem. It looks like a 9.
It's a.
That's a whole
it looks like a G.
Let it go, be Elsa, work out the problem.
It's a 9.
But that's still a 9 for no reason.
I'm on the bench you messed up.
Y'all are too. It's a 9. It's the font. Because there's other 9s at the bottom.
Or are they not?
Alright, what'd y'all get?
Okay.
So you should have got a decimal, right? Awesome. And we're not afraid of decimals, are we?
I
Why?
mean, kind of. That's what some of my.
Oh my gosh, guys.
I'm more than imaginary, and they're not exact.
Stop screaming. I mean, yes it is.
Whenever I see a decimal,
Like, imagine a person coming at you who's like, oh, 0.2 of a person. And like,
Oh, 0.2.
like he was 6.2 person, not 6 person.
That's called that you're not really 6 feet tall. You're 6 feet 2 inches. So that's a whole 6 feet 2.
Some random
No.
6'2" come at
2
you.
centimeters.
Like, he was solid 6 feet, that 2 inches gives me confidence. But like, the fact that he's.
I'm so tired of talking to you. So you got this, right? 11 equals 4x, so 4x equals 11, or negative of some sort. And then you divide both sides by 4, and you get what?
That's 0.75.
whenever I see a decimal, I think I got the problem.
Why?
Can you tell me what you just did?
I said I'm equal to each other.
That's what I did, but every time I do it, it's like, you really
Did you subtract x?
first,
What'd you do first?
subtracted 9 or 82 first.
You subtracted 9? Okay, that's okay. So if you subtracted 9, then you got x equals 5x minus 11, right? Alright, so then you need to move that 5x over here. How would
At the end,
Yeah. Alright, let's look at number 3. I love this problem. Number 3 tells us that FK is 5. And we're going to stop talking while I'm talking, and I'm not going to tell you again, or you're both going to have to spend attention when they scraping gum off the bottom of my desk. Thank you. Alright, it tells me that FK is 5, and FG is 13, correct? What kind of triangle does this make? What do we know about the intersection right here? They intersect at what kind of angle?
Right.
A right. So if this is 5, and this is 13, what did I just make?
Right.
Redraw it right here. Now, we are looking for KJ, and we'll come back to that part in a minute. Because they bisect. It's magic.
Oh, I think it's okay.
They bisect its magic. So if we're finding this, that gives us the same thing as this, correct? Okay. Now, what property did we talk, what theorem did we talk about yesterday?
Pythagorean theorem.
Pythagorean theorem. And what is Pythagorean theorem? Okay, that was creepy muttering. Now, what do we know is C this time? 13, because the C is always across from the 90-degree angle. So you get 13 squared. Now, it does not matter what you plug in for A and what you plug in for B. But we're going to let this be x squared plus 5 squared. Okay? Like, are we working it out, or are we just writing this part?
Are we working it out? Because I'm working it
That's what I'm asking.
out. Okay, well, I'm doing it.
Okay, great. Everybody work it out then.
Wow, thank you.
Look at you taking the initiative with other people being lazy. Life is gonna just knock some of you flat on your tail.
If it'll make you happy. You know what? Actually,
How do we get rid of the squared?
Square it. I wasn't
No.
times it by 2.
No.
if I'm
Square
out.
Nope.
I
Divided
got a quick
by
question.
Nope.
I got a quick question.
Yes.
How'd you get that?
13 squared is 169. 5 squared is 25. Then I subtract 25 from both sides and I get 144. How do you get rid of a squared? Square root. Take a point. I'm sorry. Take a point. If you don't know what the square root button looks like on your calculator, it looks like this.
I don't like doing squares.
Don't care. And what's the square root of 144? 12. So if GK is 12, what's KJ? 12. No. Mind blowing? Because we're applying Pythagorean theorem, y'all's minds are blown?
Woo!
No.
I feel like when we go to last year,
Why'd you get,
Yeah.
still get
I don't have anything over anything. Because we're not cows.
okay.
But this is a square root.
Yeah.
Because to get rid of a squared, you take the square root.
So why did it
Because it's x squared, it's not 2x. It's x times x, not 2 times x. Hey, you're doing number 4 this weekend for homework.